I have to say that the shoe tying actually has more additive world value than anything else I will tell you today, but that's online, so you should look that up. And if you have Velcro, don't bother, I guess. So I'm here to talk about putting SRE in your shipped software. So quick show of hands. Before I go to that, that's me. I don't think I look like that anymore, but that's still me. So how many people here run like a SaaS product of some type, right? That has one globally deployed copy that you, in theory, is somewhat consistent, that you troubleshoot. How many people ship a piece of software to someone, either via open source or your SaaS product also is shipped as a software subscription? So substantially less hands. As you start to release products, a lot of these large companies, they bequeath the projects that they build internally onto the world as open source. And they're usually up for a pretty rude awakening when they have to ship their software and it has to be run for the first time by someone other than them. That's the world that I've been in for the last 20 years, is running other people's software. It's deeply angering experience. It's depressing, mostly angering. System administrators are angry people because they have to deal with other people's software. So the one thing that you find at organizations, how many people here have changed jobs from one SaaS-oriented company to another? And you got in and you're like, your tools are crap. Like, why do you not have what I had at my last job? And the reason is because not enough of you are sharing. It's the first reason, that you don't have the same tools. But there's some like deep truth underneath that is the software that you were building was not as good as it could have been without the other supporting tooling that was in the platform, the metrics platform, the distributed tracing platform, the log analytics collection platform. Like, you couldn't really run your software unless you had that stuff also. And then you took your technology, you open sourced it, you brought it to your new company, and you're like, ooh, where do I put my logs? Where do I put my metrics? Things like that. So the nature of the problem that we're dealing with is that software sucks, and all of it really sucks. I've written probably about 3 million lines of productionized C code in my life. It runs on everything. So if you're running an iPhone or an Android, I'm sure you've got some code for me somewhere. It all sucks. I'm so sorry. It is really tied together with loose string and hope. Every time I work on databases now, I write a database, and every time something doesn't get stored to disk, like, the last place I ever want to be is looking at someone's firmware code, because it sucks down there too. So this is the turtle stack is literally true. Like, everything that you build your code atop also equally is kind of bug-ridden. So why would you ship software in the first place? So this is sort of the context for the talk. Why would you ever do this? It turns out that people feel like they can't put critical data into someone else's architecture a lot of times. Like, you don't have the right compliances, you don't have the right procedures, and they want to keep their data behind the firewall. So a lot of times, anybody who runs a large SaaS company in sales knows that they lose deals occasionally because people say, I would love to use your product, please ship me your product and I will run it internally. And they go, F you. And then the deal's over, and you don't do it. So we don't really take that stance. We run a SaaS product at Circonus, but you can take all of that software and you run it on-premise as well. So there's some interesting things that you learn in that process. Is one, not trying to disparage our customers and the people who operate our product, but no one will ever really operate our product as well as our operators will operate our product, right? Which is the carnal knowledge is just there. So there are general rules that I think everyone would know, having worked in the field of SRE, is that when you fail, you should fail fast and you should fail in a controlled way. Post-mortem analysis is an absolutely fundamental concept in systems design. If you do not know why your system failed, you will never get better. The use of circuit breakers, so the idea of being able to handle a hostile workload in a way that doesn't damage the system, right? The system integrity. Turns out it takes a lot of money and time to bring a system back online from failure. So it's much better if the system just malfunctions and denies service to users so that it doesn't have to be brought back online, right? To have it stay alive through a hostile environment by using things like circuit breakers, right? It's like, I'm overloaded, I'm just not going to provide service right now until things are okay again. It means that you don't have to have an operator come back in later and try to reboot the whole thing and get it back online again. Behavior is complex. I think that's been a theme so far in the conference. Having a failure budget is a really interesting thing that I don't know how many people here do failure budgets. If you're doing SLOs, SLIs, and things like that, the next step would be to have failure budgets and actually use those to increase velocity or throttle velocity. And then the last thing is that in all of this, instrumentation and observability. I like to say observability and O11Y as separate things because they sort of do mean separate things, and I mean both of them. So the newer concept of observability, which is kind of sort of online systems oriented, and the older term of observability from control systems, like the understanding of how systems are observed and what that means. I'm going to get into like brass tacks of what this means and why they're different when you ship software. So the first thing is that when your shit explodes, it is absolutely fundamental that you understand and can diagnose that failure for a permanent solution to that, right? So the can I turn it on again, turn it off and turn it on again thing, I have done that within the last 24 hours for a piece of technology. If you are shipping a product to someone, that is not the right support answer to give everyone for the next year, right? So when something breaks, it is absolutely fundamental that you get stack traces, core dumps, you get all of these various things. So I will share what we use internally. We use a tool called Backtrace. It's a service, and we write most of our stuff in C. There's some in Go, but most of our stuff is in C. And when we have a failure condition, about 35 milliseconds later, we get 300 kilobyte mini dump effectively that shows me every thread, every stack frame of every thread, every local variable in every stack frame. I can navigate around it in my UI. Shows me the line numbers of the code that it was on. And I can see in this trace, for example, very quickly that this was a watchdog timeout and it happened while I was doing some sort of C++ destructor. And I know the line of code that I'm on, right? So now I can give this to an engineer and said, hey, we had a watchdog timeout in one of our threads, and it was destructing this list. And they go, wow, that should never happen. How many times you put that shouldn't happen? That's crazy. I mean, like, how long does it take to free something? So then you kind of navigate down in the stack, and you look at your search results, and it says 320 million search results in your search query. So it turns out when you run a time series database that supports large volumes, when someone does, I just need to know what metrics are in the system, let me search for star, and it pops back 320 million different names, that it can actually take a really long time to free the memory after you give it to the answer to the customer. So this is really funny. We're trying to figure this out, and it's actually sent like a 30 gigabyte payload back to the customer already, which of course they didn't do anything with because there's no way they could have eaten that. It's probably into some Ruby app, and it was just like, and then it freed it, and then it was just like, look, I am taking too long. And this is a double example of circuit breakers. So the application intentionally crashed. Not because it did a bad memory reference or anything like that. It's just like, I'm doing something and I'm taking a really long time to do it, and I don't feel like I'm a good member of the team right now. So, and guess what? It restarts and comes back online and everything's good. So this is like resilient, anti-fragile system design, right? So the thing just murders itself when it finds that it is not a cooperative member of the party. But this type of tooling, the important thing here is that this is a multi-layered tool. So when we ship this to customers, a lot of them that don't want to put their data outside the firewall, they also don't want to send us stack traces. Super annoying, by the way. But it actually drops this little 300 kilobyte file, which we can have on all the time. So the system is always dropping these traces when it crashes. So then I don't have to instruct someone how to turn on core dumps on their various flavor of operating system that Chef or Puppet will immediately undo after they do it. And you spend like a week trying to get somebody to generate a goddamn core file. So this tooling basically uses, it codifies the experience that we use in our production environment and basically ships that on premise to customers. And If in the best case scenario, within a second of a crash, we actually know. The customer doesn't even care. The system crashed and restarted, no users were impacted, but we already got a stack trace and it already went into the product development pipeline. In the worst case scenario, they don't want to send us the core files, so then we call them and then they send us the core files manually. Exposing telemetry is another thing that is absolutely critical. These are the known unknowns, or the known knowns of your system, if you think about it that way. So there should never be a system. I mean, this is a goal for anybody who's running any sort of production software, and this is why putting developers on call is so powerful. Like that should never happen. Happens all the time, right? You deploy your code, and it's like, well, that should never happen. It's like, well, what could cause that? That would only be caused if the search results were really big. Well, how big are they? I don't know. That's a really shitty answer, right? The last place you want to be is looking at something after hours when it's broken, or even on hours, it's in production, and you're like, well, that could only happen if this constraint was true. Well, is it? I have no idea. Like, we'll add the telemetry, right? Like, put the metric in there to expose that piece of information, right? So it's really important. So one of the things that we do is that we track every single thing. So we generate more data out of a single database node than typically it ever ingests in its life. So every disk IOP, every KV manipulation, every storage record, every read, every nanosecond latency of every single one of those is measured and stored. So we have a full histogram of every single transaction, when I create a new event or allocate memory, the number of nanoseconds that takes, that's tracked. Number of clock ticks it takes. Cycle counts, all of that stuff is all tracked. It turns out it takes like a day to implement that sort of stuff. Computers generate that data really quickly. It's really easy to get instrumentation library to jam into your application. So it's really great. So then when you go into the thing and it's like, well, the search queries are really slow now. Like, what changed? I can go and look at every single thing that's happening inside the system, and I can get historical data about every single thing that's ever happened, right? This is invaluable in troubleshooting a problem, right? When I have a question, I have the data to back that up. So this is what you should aim at. The important thing is that pumping all this stuff through like Grafana and building Grafana dashboards is awesome. You should totally do that. That's great. Or you should use our product and do it with our product. That's great too. The real thing is that when you've shipped the piece of software to someone else, they may not have Grafana. They may not have your product or our product or something like that. So it's really critical that you have some simple way to extract that data out of the product natively. And this is what I was talking about when you forklift your technology from one company to another. When you rely on the orchestration framework and the deployment framework and the metrics framework, suddenly your application is no longer operable. You have this problem because you were relying on these other infrastructure components. You need a minimum viable product of operational substrate in your application, in your library, or whatever it is that you're shipping, so that when you ask a question, you don't give someone that fuck you answer that says, oh, well, you need to set up distributed tracing with Jaeger to know anything. It's like, what? I just want it to work, right? So that's really important. It's really true with things like events and distributed tracing. So understanding what happened, giving a concept of the way we use tracing. So we use Jaeger. It's a product, an open source product out of Uber. And we implemented in our kind of framework library for all of our applications, which is open source, called libmtev. If you're writing high-performance C apps, which anyone write in C? There's no hands that go up, right? 2. All right, so if you're writing high-performance C apps, it's a pretty baller framework. It has distributed tracing built into it. All of the like Zipkin spans and things like that can get generated. We generate spans for everything. It's an option. I mean, you turn it on, but not only do I start a new distributed tracing span when a request starts, but when I have like an eventer fire for a readable socket, it fires. When I create a job and run it in a job queue, it runs that. I have a span for that. So when I do a simple thing like search for metrics that look like go_GC star, and it returns me like 20,000 metrics, the span, the Zipkin trace in this will have 150,000 spans in it, easily. And that's like a 20 millisecond long query or a 10 millisecond long query. It'll generate 100,000 plus spans. And our developers can look for anything in there. And what happens is that's normally generated into the ether, but you can just connect Jaeger to the device. And as like operators of the product, we can SSH tunnel in, connect Jaeger in, and then run the trace again, and it'll all show up right in our dashboard. So it's an invaluable debugging tool for this. So the distributed tracing stuff, we don't kind of productionize this, and we don't offer it to our customers, but it's something that we use internally to understand not only dependencies between different products, or different microservices in the platform. We use it to understand latency profiles between calling requests. So we can understand exactly how long each operation inside the system takes. And this is like one of the intentional reasons that we don't use a third-party product for our distributed tracing, is because if you've seen the pricing for third-party products with distributed tracing, when I say, how about I send you one request? And they're like, sure, yeah, an average request is like 4 spans. It's like, okay, that's not gonna work. We have 150,000 spans. The thing can generate probably around 2 million spans a second out of a normal instance. That's like a ridiculous bill. But with using something like Jaeger, we can have a really custom retention policy and answer all sorts of really interesting support questions. So basically what this does is it just provides us yet another avenue to understand the behavior of our system when we really need to. It's like most of the time it's not really doing much work and kind of not storing it, but when we're interested in doing it, we can kind of attach the pipes together and we get all of those answers out of the system, which is great. Logging. Logging is for humans. So this is one thing that I think that the industry will eventually come in on, is that you talk about structured logging and you talk about logging. To me, structured logging is for computers. You have one solution that, a lot of that looks like events, a lot of it looks like distributed tracing. All of those things are types of structured logging. And then you have logging, which is like, how many people have done printf, I am here, console log? Yeah, no, that's not for a computer, right? It's not useful. Totally useful for a human, right, to understand how that's working. So logging, having logging there, I think that when you realize that logging is for humans, the first step is this will be useful to me. The next step is realizing that that log may be the opposite of useful for someone who is not you and not familiar with your product. So when you deploy a product like MySQL or MongoDB, if you were actually getting like developer-centric logs in there, no one would ever understand what's going on. So when you start focusing on shipping software and you start talking about logging observability in there, you start to treat it like a product. You start to treat your service like a product, and you start to think about how can these logs make the life of an operator of this product easier. So that's really, really important as well. Dynamic tracing, I have like a really soft place in my heart for dynamic tracing. So one of the things, this is why I talk about the difference between like observability and O11, why. So there's one misconception in the world of like known unknowns and unknown knowns and known knowns and unknown unknowns. And there's a lot of talk now about kind of these observability systems that provide you access to answer the question around your unknown unknowns, which sounds awesome. That's what I want. I want to be able to solve problems where I don't understand or can't predict the input, don't know what the output is, and I have no idea what the hell the question is until I want to ask it. Well, it turns out that most of these products are like, okay, well, to start, go add something to your code. It's like, well, if I add it to my code, by definition, I fucking know it now. So it's not unknown unknowns anymore, right? So the important part about distributed dynamic tracing is the idea of being able to instrument a system on the fly with no context. So this has been available forever in dtrace in every platform that you've run, except for Linux. How many people here run Linux? There you go. All right, so it's not been available to anyone, effectively. But now eBPF, as of like Linux 4.7, really supports the vast majority of those capabilities. And things like BPF trace will allow you to do this. It allows you to go in and ask questions. And these are the really cool things, like that search results example, right? It's freeing search results. Well, why would it be that slow? Well, I mean, only if the list size was really huge. Well, how big is it? Well, I don't know. So the usual answer to that is an engineer goes back to their code and they add a metric in to track search list sizes, and then they do that, and then they wait a couple days and it gets redeployed. If it's a database, you may wait a couple weeks. And then now you have this and you wait for the problem to happen again. With dynamic tracing, the memory on the box is yours. You can go in and say, hey, I want to find this opcode where this function is called, and I know that like 8 bytes into the structure is an offset that has an integer in it, and I would like to print it out anytime I hit that. That's an unknown unknown, and with one line of code, you get that answer, and you can see all the search results and exactly how big they are. And suddenly you have like really deep insight into that application. So this is kind of the last tool in the tool belt of understanding systems behavior. And it's super effective when working with both productionized software that's deployed in your SaaS, but also software you've shipped, because the scripts end up being really tiny. It's like little Perl scripts or little awk scripts. And you just say, hey, the client, just run this thing. And they just run it on the command line, and they get your answers, and they give them back to you. And the beauty of that is that it doesn't require software redeployment. How many people have had a bug in a piece of software and they've restarted it and the bug has gone away? Like, repeating it in the test lab is the best FU to any customer. Like, oh, I'm sure you have that problem. Let's try to repeat that in the test lab. It's like my proof point isn't enough for you. Like, it's broken right now. Why do you need to repeat it? Dynamic tracing actually really gives you the instrumentation and the questioning framework to be able to answer questions live in production without disruption, right? So this is a really, really powerful tool. And I think as BPF trace becomes more popular, it'll become more accessible to everyone as well. So I'm really excited about this. Sort of the last two things are wrapping all of these things together. And these can't really be understated. So when you look at things like monitoring and observability and instrumentation and all of these different things, requiring a large apparatus that's specifically one that's custom inside of your company isn't a really good experience for that product. You really want the operator of that product to not have to really leave the tool until they want a more comprehensive view of that. So when you have things like metrics and you have stuff like distributed tracing and you have BPF and you have all of this stuff, it's great to send that into your overall, company's framework for analyzing it, but it's also incredibly valuable to be able to remedially review that right in the app. To have like a little dashboard in the app to be able to show the data. Have a freaking JSON URL that you can dump it out and put it into ggplot or whatever, right? You really need to be able to interrogate the app itself without using all of these surrogate systems. And you see that more and more as you have these complicated dependency cycles where it turns out that your monitoring graphs don't show up because they actually needed the system you're trying to debug right now, right? And as we build kind of our shit show of microservices in the world, those dependencies become like really, really obtuse and hard to manage. So the more you make each individual product that you ship, each individual service or app or node, more self-sustaining, then you basically have more power in analyzing its behavior. You don't have to participate in the overall ecosystem to understand how it works. The last thing that shipping software forces you to do, and this is a really painful thing, so if you can get away with not shipping software, you can kind of cheat and skip this step entirely, is that everybody has playbooks. Everybody has operational assessment and procedures that they do, right? When things start to fail, when things break, when something slows down, you have steps that you take as an operator of that software to interrogate the system, to try different things, to try to remediate the problem, right? You want to try to gain understanding and then achieve remediation. When you're trying to get somebody else to do that through a game of telephone, it never works right. So it forces you to codify those things. Those things stop being things that you do, and they start being automated tasks that you trigger to be done. And then eventually they turn into product features where the product self-heals and self-maintains. So it's amazing how often when an engineer is faced with a challenge, they come up with a set of solutions, but if you ship that product and they can't apply them, those solutions turn into product features under the hood. So really it's about turning tools into solutions. And I think the most important part of that is that every effort that we spend bringing SRE techniques into software engineering makes our entire ecosystem of techniques more accessible to every single person that wants to employ them. It's not just for people who write software and deploy software, it's people who operate it. Even if you're operating software that no one else will ever see and you only operate one copy in the cloud, if you think that you're shipping it to someone else. This is actually controversial opinion. It's something we lost when we threw over things to the ops team. When the developer team built something and threw it to the ops team, nobody talked often enough about the off team put it in a bag, lit it on fire, and left it on the dev's doorstep afterwards. Like, I'm not running that. Like, ops teams had the privilege to say, F you, I'm not going to run that in production. It doesn't work right? So in order to speed up that life cycle of software development and deployment, we kind of merged all of those things together. I think it was really healthy. But what happened is that a lot of the kind of the minimum level bar of good software development that ops kind of in their hateful way imposed on software development kind of got lost. And there's a lot of software that's half-baked that goes into prod now because we're DevOpsing, right? And that's really not what you're trying to aim at. So as we start to codify these techniques into the software themselves, it makes everybody's life a tremendous amount better. I think it really advances the whole SRE movement and kind of in large as well. So that's it. Thank you very much. Anybody have any questions? No. Quiet.
What is that backtrace tool?
Backtrace.io.
Can you repeat the question?
The question was, what is that backtrace tool? There's an open source tool that they released called ptrace, which does all of the kind of mini-dump capturing of binaries. I think it works on Go and C and things like that. I think the only one it doesn't work on is Java. And then they run a SaaS service called backtrace.io, which will collect and categorize all of your stuff and integrate it with Slack and Jira and all sorts of things. It's pretty cool. It has literally moved 7-day engineering efforts down to like 15 minutes for common tasks for us. All right, well, thank you very much.